All right. So as you can see on the slide that I'm sharing there, I kind of missed the whole green heron boat when it first launched, but I've been in a lot of ham shacks with them. And this past fall, I was contemplating a new rotator controller after I had to put my tower back up after some housework. And researched a bunch of solutions, but then came circled back to the Green Heron. So I ordered up myself an RT21, and I'm super pleased with its performance and the way it's built and all that. So as you can see, Jeff has been licensed ham for a bit. I think I was, let's see, 6 years old in 1960. So he's been licensed for a long time. He's done a bunch of contesting. As I mentioned, he shows up in my logs quite a bit, and he's got some good experience from D expeditions and stuff like that. Jeff founded Green Heron in 2005 with the RT20, and he's talking about shipping his 6,000th controller earlier this year. So at that point, Jeff, if you want to, you have anything to share here, we can get you up on the screen.
Let me see how I do this. I don't do this very often. I'm going to go show my entire screen.
You can, or a specific screen. So hit the green square box down at the bottom of the.
I did that.
Okay, and then you got to select the screen.
Yep. You have my screen now?
Yeah, that's your entire desktop, it looks like. All right, then hit the thing that looks like a
Yeah,
movie screen in the bottom there.
how's that?
That's excellent. We see your presentation.
Okay. I'll try to hold this to well under an hour. We'll see how it goes. This is originally something I did at Visalia a number of years back. I don't know how many people you got here? 60?
No, we're in the order of 49.
Oh, okay. I see just a few names and a couple of customers. I see Fred's in here, and hi, Fred, bunch of others. Anyhow, let's just get right to it. We started with rotor controllers when I first started building my station, which turned into multi-multi in 2000, which is the first time I had a station capable of more than just multi-single work. And I just found some problems with rotor controllers that I couldn't, things weren't accurate. We were always recalibrating and having all kinds of trouble the first couple of years. So I just went and tried to build my own, and I did. I wasn't planning on making a product out of it, but it just happened to work out that way. I kind of fixed the performance issues that I found and figured out a way to modernize it and make it universal. And like the opening slide said, I never envisioned going to 6,000 controllers. I figured a couple hundred would be it in a few years, but we've been going now for 20 years, and it's been quite interesting and fun. The actual product itself, the RT21, is really the same thing we originally came out with, except it's had incremental evolution with features, ruggedness, and the latest versions add embedded web server and TCP as an option. Amateur is about 90% of my business. More and more we get commercial. Especially with the ASL, we're doing a lot of commercial ground stations on our ASL controller. But the primary thing I wanted to talk about was GH Everywhere today. That's it's kind of an unusual concept. I'm not big into marketing. I'm a single person company with 3 part-timers or contractors. We build everything in the US. But anyhow, this is another solution that I needed to, or problem I needed to fix. And the groundhog started eating up my control cables after 4 or 5 years at W2FU. And I was just getting out of my last actual job, which was with microwave data systems, and we did wireless telemetry or SCADA systems using 900 megahertz and 2.4 gigahertz radios. So I borrowed that architecture and originally decided just to see if I could replace cables with wireless control, and that worked. And went on to the next obvious thing was to go ahead and build a multi-user software server client application that would allow use and get rid of a lot of the problems with lots of cabling and switch boxes and stuff. So we did, and in about 2012, we started using it at W2FU and released it to the general populace and a year or two later. Essentially, GH Everywhere is aimed at antenna control, switching control, and automation. It does local and remote operating. Primary uses of antenna switching, but it could be used for anything that you can turn on and off with a relay or a switch. We also decided to add the rotor control through to it. The rotor control can actually run either direct off the server or over a wireless link too. Essentially, like I said before, anything that can be controlled with a switch or a relay, we can implement into the GH Everywhere environment. By doing a software-centric approach to this, there's no dependencies on radio choice or band decoders or your actual switching devices themselves. Because you can use this with a DX engineering switch or just about anything else out there, with a couple of notable exceptions. Doesn't work with the shack LAN because that's a proprietary LAN system. And I think that's the only one that I can remember right off the top of my head. What advantages do you get? Local control for local contesting or local operating or internet, whatever you do, it's an identical operating experience. This is independent of the radio control. We do everything except the radio itself. So it's an identical operating experience regardless of where you're sitting. We eliminate the tethered control switches and cables, which promotes the ability to reconfigure a station very quickly. The operating locations could be, well, I can operate here from Florida, which is where I am now, or sit in a chair in New York, and it's exactly the same. It reduces station clutter dramatically, automates the antenna selection based on radio frequency. It easily integrates with any switching device, again, anything that can be controlled with a switch or a relay, whether it's a manufactured one or your own. And optionally, you can go wireless all the way to the control devices, which allow you to add flexibility to where you put switches. If you want to add a new band switch or antenna switch out of the tower, you don't have to run a control cable to it. You can move it to a different tower, and you don't have to do anything because it's wireless. We do have a range of close to a mile. I'm running them 1,500 feet or so. Using wireless adds a lightning barrier, which is a very nice feature. And with the price of copper today, it's almost cheaper. In many cases, it is cheaper to do it wirelessly than it is to run a new control cable. From an automation aspects, GH Everywhere gets its frequency data from the radio via software, gets it from your logger. There's no need for a band decoder, so you can change radios. It's radio agnostic. Instead of a band selection, we get resolution to 1 kilohertz. Advantage there is you can, excuse me, get my water here. Get resolution to 1 kilohertz for switching, which allows you to make things like an auto tune 160 meter vertical. As you start tuning up the band, it changes capacitors or whatever you might want to do. A lot of folks are using them on tornado tuners to tune 80-meter beams. It gets a direct frequency from these programs, N1M, DX log, right log, WinTest, DX Labs, N3FJP, and FR Stack, or indirectly through Cadret's nice program, PST Rotator, which has the ability to get frequency from just about anything. And it generates UDP packets in the N1MM format that we can directly use. What does it automate? It allows you to show different devices on your screen based on the frequency of the band. It can select switch positions based on frequency. You can tune a tornado tuner. You can do rotor control if your logger supports a rotor packet, UDP packet in N1MM format. It can automate that and do the rotator selections for you based on your band. And what we're just working on now, which is in a test release that's actually up on the website, is we can send serial or TCP or UDP messages based on frequency. That's nice for a lot of the newer radio controls where you might want to change something. I use it to change K4 settings depending on whether I'm on microwaves or not. And got a customer who's very into using this now on by controlling an antenna tuner that works off TCP. That's a couple-year-old picture. Does this show up well enough to talk about? This is one of our multi-2 positions. We have 2 positions that are pretty much identical. This is one of them. This operation is it must be from NAQP because the amp is off, and we've got 2 guys in the chair, so they're doing in band on band. I think it's 15 meters. But each one of these positions has access to all 6 bands, HF bands, plus 6 meters. We don't care who's run or who's mult or who's S&P, and either position has the same exact capability, both in the radio control and the antenna selection. You can see a couple of GHE stuff here. I'll show much better pictures of this. But there's no blue switch boxes. There's no cables hanging everywhere. There's no rotor controllers. Everything's off the positions. It's all either in the back room out at the tower or just outside or somewhere. It's not here. Everything can be controlled from on-screen stuff. So what else is notable here? The reason this is another K3 here, in fact, there's a YCCC SO2R box. This position can be reconfigured just with software to be a SO2R position. The only difference in operating is this radio is cabled to the second amp, which is on a different port of the matrix band antenna switch. So the left radio here is going through our arbiter box and then all using the left amp and the left set of antennas. But if he wants to switch over to this one using the SO2R box, he could go on a different band. Typically, this is just for an SO2R sit down. But when you're using the left radio in conjunction with this one, it's in band. They're sharing 15 meters. I think this is one's running and one's S&P in. The only hardware on the operating position beside the SO2R box and the radios and the computers is this little arbiter box, which is our little secret sauce to do in-band radios. The building blocks of Green Heron Everywhere software. It's a software-centric system. There's a server that runs on any computer. It manages the hardware and connections to various clients. There's a client software that runs at each operating position. This is a true multi-user system. So every client has access to the same things, but every client can be configured separately. It's the client that integrates with your logging software for that particular operating position. Then there's a wireless base device, which is nothing more than a little box with a USB port on it. And although it could do switching, there's reasons why you might not want to use the base for switching. And it has a wireless module that then connects to the wireless remotes. And the wireless remotes are your primary interface to switching devices. The remotes handle 8 bits of switching and a serial port. So each base and each set of remotes create a wireless cable network. The way that's architected, you can start small. You can run GH everywhere with just a single rotor controller, and that's it. You don't need to do any switching. Then you would need absolutely no additional hardware. The software is all free, and you can download it on the website. If you want to add switching to it, you can just add one base and then add your switching to it as you grow. You can add bases to the server to get additional multi-point networks. I use multiple bases in order to segment out or different locations so I can reach them and design RF networks for them better. I've got one network that reaches for the backfield for the towers. I've got another network that's for inside use, and I've got a third network for the front field, which is where our circle receiver arrays are. And each one of those bases has an antenna to it that optimizes for that network. Each base can handle 254 remotes, so you can get a pretty big system. I'm actually using about 25, maybe 30 remotes now. I've lost count. There are some out there that are almost as large as mine. I don't think there's any that are as large, so we make a great test system. Practically, there could be some performance considerations if you started to get 30 or 40 remotes on a single base. Although the software is designed to reduce lag in switching, you could run into some issues depending on what the applications are. You can run any number of simultaneous clients into the server. You can actually run multiple servers, and we've done that occasionally. So a single client can connect to servers at 2 different locations or multiple servers in the same location. Everything is an open architecture. The wireless protocol is a standard. There's an industrial control standard called 802.15.4. We use the XB chip because all the FCC type certifications come with it for free. Everything is, that protocol is open. All the TCP commands are plain text XML type tags, so you can the protocol between a client and server is open, and in fact, every command is shown in a server log on the server. Every time somebody connects or issues a command, you can see what that command is. We've had a number of our customers create their own client. I think there's some clients out there that the league is using for that use Node-RED for a user interface. I'm not quite sure what that gives them in addition, but they use it. I should say most of the configuration stuff, anything that you might be interested in knowing how it works, is all in XML configuration files, which again are human readable. The server is a true multi-user system. It's actually written in Java. It was done back in 12 or 13. I didn't do the original, but I do all the maintenance on it now. I had a very smart fellow help me doing the original software. Although it's designed for Windows and I really only support Windows, I have run it on a Raspberry Pi. I've got customers that have run it on Macs and Linux boxes too. So it could be used on other platforms. The server connects to and manages all the devices, the switches, the RT21s, all through the USB port on the computer. All the devices are defined as in standard XML, but we have a built-in editor that shows you how to create a device or configure a specific device. Plus, there's built-in ones. We built in devices for stack matches and rotor controllers. I'll show you why in a little bit. The server accepts commands from the clients using TCP/IP in human readable text. And again, each command from a client is just printed out in a log file in the server, so anybody can see how it's all done. Optionally, we do user authentication. You can make the TCP port. It does require a port forward in your router for remote access, not for local access, of course. And it does full transaction logging. And the log not only logs to screen, you can log it to disk. The clients are the operator view, and they're what says what you run on each station. In some cases, you might even run 2 instances of the client. We have a special instance for SO2R. Each operator can configure and lay out his own screen view the way they want it. If you're in a multi-op environment, it's nice to make them pretty consistent so people can change positions and know what they're doing. But for a single op scenario, you can create your client for a single op the way you want it. And again, like the server, although it was designed for Windows, it's all in Java, and there are actually no dependencies to run the client on a Mac or a Raspberry Pi. If you can figure out how to run a Java program, the jar files are freely available for download. It does integrate. It's the client is what integrates with your logging software. It's what generates the frequency dependencies. And for contesters, this is a key thing. We like to use the hotkeys. So now keyboards, you can start running out of keys pretty quickly, but we found that the little numeric keypad is a great thing to use for your control. And the way it sets up that it only shows the on-band controls and only makes them active for the frequency you're on. You can reuse the hotkeys, for example, on stack matches. You can use the same set of hotkeys to switch the 20-meter stack match as you do the 15-meter stack match. Keeps your hands on the keyboards. Although anything can be reused with the mouse, there's no real need for most features or most functions to ever use the mouse. And we have lots of customizable features. It works well with touch screens. You can change the size of things. You can add your own custom map images for directional antennas, rotors, or switches, colors, etc. For a rotator standpoint, the operator can turn their rotators from logger, from pop-up presets. You can jog a rotator, go to direct heading entry, use hotkeys. You can mouse drag on a map, or you can use touchscreen. For switches, you can either switch a switch automatically if it's based on frequency. You can use the mouse. We prefer the hotkeys. Touchscreen's a nice option too. You can run a touchscreen display. We did this once. You can run a touchscreen display on a laptop that sits between 2 operators and they can share it. The client does not have to be running on the same machine you're doing your logging on. You can have clients all over the place and still link them to an instance of your logger that's running on a different machine so it can do automatic band changes. But it also allows you to centrally locate one where you might want to manually control a set of buttons or stack match or whatever. The base is just a little thing like this. USB as it gets its power. It shows you the signal to the currently transmitting to your remote and the activity on the USB bus. The actual wireless device in there is a XB chip running 802.15.4 with the high power unit, 63 milliwatts, and external antennas. You can get to about a mile if it's unobstructed. Obstructions have naturally reduced the range. It's a pretty small, convenient packaging and relatively inexpensive little device with single strength LEDs. You can add switching to the base. It does have an I/O slot to be able to add switching. We typically don't recommend it, mainly because you lose a couple of things. You lose the ability to put your remote or to reduce your cable length to as short as possible, or allow you to move it around or move your switching device around without having to run a cable. And with connecting your switching right to the base, you lose that lightning barrier. There is a PTT jack on the front that allows you to put this particular network, that is this base and all its remotes, into a sleep mode for hot switching control. So this is a high impedance PTT jack. You can parallel it with the key line to your amplifier, and it will put the network to sleep while you're transmitting. And as soon as it quits transmitting, any switch changes that were requested will take place. Not too many people use that. I don't use it. We've used it, I think, occasionally when we're doing 160 meters with two in-band stations and we're not in the same room. I'll use it then. But to my knowledge, in 20 some odd years, 25 years now of multi-op contesting, we've never had a hot switch failure. Let's see. Okay. The remote looks a lot the same, except instead of a USB port, which it has none, it's powered from 12 volts, and it has a serial port for connection to an RT21 that's out in the field. It also has its 8-bit of switching capability. There's the back of it. This is with a 8-bit relay module in it. You can use a board, the board itself, and use a header connector to get to your device, or you can use the pin plug on the back, or the terminal block on the back. It's DC powered through the front or the back. It's got 8 bits of output control. Each remote could be split among multiple switch devices. So a logical, for example, a stack match takes 2 bits or 3, depending on the type of stack match, or actually more bits depending on the type of stack match. But you could use one of these to control 2 different stack matches, or one of them used to control a stack match and a 4-score controller. You can split the physical device into logical. Plug-in modules, there's an 8 relay, there's a 16 output NPN and a 16 output plus source module. The 16s are primarily used, or almost invariably used, for matrix switches like a 8x2 or an 8x4, where you're only going to have one position in a 1 of 8 configuration. There is the ability to put these to sleep. Got a couple of customers who use this, not too many, but it's there. You can configure the remotes to operate in a sleep configuration, where when the server stops stops communicating with them, or the base stops communicating with them, the whole system goes to sleep out there after just a few seconds and draws just a milliamp or 2, wakes up every 30 seconds and listens for a signal from the base. If it hears it, powers itself back up and stays awake. It's pretty cool, but not too many people are using it. There is a serial port that's on a header inside the base for accessing a remote RT21. Here are some of the devices that we make. This is an outdoor remote. This is the remote board. Is my pointer moving? Here, I can do this. There.
Yes, we can see your
This,
pointer moving. Yes.
this is an outdoor remote. Um, there's a bias T, so you can power it through the coax. That's what it looks like underneath. So you could mount this to a tower leg or to a post. Most of our customers just have outdoor boxes to put their stuff in anyway, so they don't use this, but it is available. I guess I don't have the other stuff right on this side. Okay. So for displays, um, each rotor, there's a rotor display type, and the rotator, of course, turns an antenna. You can't have rotors, concept of a rotor without being something that you turn. For example, a clone rotator. A rotator actually turns it. A clone rotator is an antenna that turns along with another. So if you have a 20 meter and a 10 meter on the same mast without an offset, you can make a clone rotator so that you only show the antenna you want to turn on the screen and not show both of them. I'll show you why that's important. Rotators can be direct connect to the server through USB or remotely through a serial port. They display as two different types of images, a tray or a map. The tray is just the digital version. The map is on a map. And you get pop-up presets or pop-up or global preset pane if you want to be able to use presets. And rotor controllers can have embedded stack controls, and that's why you may want to have a cloned antenna so that you can have an individual stack match set up for that antenna. I'll show you again, I'll show you what that. Stack controls that we support directly as embedded controls are the Ray Solutions, our own 4-stack, which is the Ham Plus with a remote board built in. The low band systems are the OK2ZAW. So here's a rotor control with a preset pane. In this case, I've got a tri-bander and a 40-meter beam. And this kind of shows a lot of the features. This 40-meter beam is mounted 90 degrees off. So we have a separate control, although it's only one physical rotator. There's one for 10, 15, and 20, and there's one for 40. And it will only show the one on your screen when you're on that band, if you set it up that way. This one's blue to tell you that it's a cloned rotator. It's not its own physical rotator. It operates the same way. You can turn it as if it was its own. You can preset it like as if it was its own. But it's in blue to remind you that it's really a clone of the rotator that's turning this thing, and it's actually 90 degrees off, hence the display is 90 degrees different. Presets are obvious. Here's a map display. In this case, again, you can show just the one you want to, or show the one that's you're on the band for, or you can show them all. You can drag these around. If it's a touch screen, you can grab the wedge and just touch it around. Well, you can't see me doing that, but I'm doing that. Here's one with embedded stacks, and this is where hotkeys become really nice. This is a 3-high stack on 15 meters. This is what our display looks like. The stack is the little green LEDs here. So this is a device where just with the hotkey, I can change which antennas are actually being run through the stack match. So in this case, each one is an individual rotator, but they don't have to be. If this was a rotating tower or a single rotator with its turning 3 stacked antennas together, then one would be yellow and the other 2 would be blue, but you still have the separate stack control buttons. And again, these are on hotkeys. So I use the divide, multiply, and subtract on the numeric keypad to turn them on and off. For switch display types, There's a set of buttons. Each buttons you can name yourself and add your own colors, either to the whole button device or globally or to each individual button. A button display selects one thing at a time. Then there's a band, which is essentially buttons. Again, this is the type of device. It's a band switch if it's going to be a set of switch positions that are optionally selected by a radio frequency. There's an on-off bank, which is a set of buttons with individual on-off controls of certain things. You might want to use that for turning on and off station accessories, things like that. You can have a map display for a switch. This is what you'd use for a 4-square or an 8-circle. It looks like a rotor, except it's controlled by switch positions, and you have the ability to rotate them around with a pair of hotkeys. Makes for very fast receive antenna switching. Great for beverages too. There's a matrix lockout. This is where you put your main 8x2 in there. If you're an SO2R person, you've got an 8x2 switch where either radio can go to any antenna. The matrix lockout allows you to manage that so you don't try to select the same band, even though the switches typically don't allow it. The software gives you double and triple protection from that. It's a visual indication of what's being used by the other station or the other radio. It's got multiple levels of lockout. Then there's a virtual switch. A virtual switch is a button or band switch that can take and select separate physical devices. For example, if you wanted to switch both ends of a long piece of coax and use it on multiple bands or multiple things, you can have a virtual switch that flips bit 1 or switch 1 of a coax switch in the shack, and also flips a relay out at the base of the tower that selects that coax to a certain antenna. There's lots of things you can use this virtual switch for. It also allows you to use a tornado tuner with a virtual switch. It actually runs a rotator based on frequency. You can send serial TCP or UDP control messages to other devices. I think the big use for this is going to be antenna tuners. Oh, okay. This is what a button display looks like. This is what a band switch display looks like. It looks the same, except it's got software control selections here. This is an on-off. I'm using one for a Flex 6600 control. I can turn it on remotely. I can turn on the amp remotely or the PTT. Map display for a switch would look like this. This is with the compass rose. The matrix lockout. In this case, you've got two different positions, or it could be two different radios on the same if you're doing SO2R. The green shows I've got 80 selected here, and we've got 20 selected on the other one. So we can see that the pink shows it's locked out. And both of these can run automatically. This one can run off radio A, this one can run off radio 2. Some of the switches stuff we build with embedded remotes. We do have an 8-position single outdoor switch. We've got an 8x2 receive only switch. This is a kind of a custom build. It's a really unique product. Allows you to use 2 non-transmitting antennas or two radios with a sharing any one of 8 or 2 of 8 receive only switches. We actually sell the Hamplus, and we private label the Hamplus 8x2 up to 12x6. I use an 8x4 and an 8x2 at W2FU. This gives you the least complex remote configurations. It's a very nice package with the 8x2 and a GH remote to do an 8x2 setup for SO2R. We also embed a GHE wireless remote inside of the Ham Plus 4 high stack. This is the Select 8. It's a nice little outdoor package. This is our 8x2 receive switch. This is a Ham Plus 8x2. And this is the 4 stack. I'll go through some of this quickly. We can ask, if anybody has questions, I can go through it in more detail. This is a sample of how you would set up a profile in the server to configure a particular switch. In this case, this is a simple antenna switch that's used on 6 bands plus an 80-meter dipole and a dummy load. You name the settings, the positions of these will be the names that show up on the buttons. This particular one is a band switch. We select just one bit out of the output for each position and a set of frequencies in megahertz, but down to the kilohertz level that show you what frequency it will take coming from your radio to create that switch to occur or to change. So band switch is for automatic band switch use. Really cool features about GH Everywhere. Really, it's overall flexibility. You can just do just about anything and move stuff around. The custom map images are neat. I guess that was a lot neater 8-10 years ago. Today, maybe not so much, but it's still the same. The sleep mode in the remotes is kind of cool. The ability to do cloned rotators with offsets or without offsets. I do some pretty interesting things with that on VHF and microwave, where it's using the same tower that's rotating my 40-meter beam, but it's offset 155 degrees because everything's face mounted on the microwave stuff. You can hide and show your switches and rotors based on the frequency or based on the current band. The support for 2 simultaneous clients on 1 computer to do SO2R with 2 independent sets of controls. The virtual switch that has lots of uses that we haven't even figured out yet. The ability to send external commands is the new thing. And the ability to share a physical remote device among multiple switch devices. It means the hardware cost is pretty minimal. The hotkey shortcuts work very well. As long as you have a numeric keypad, we find that that's enough. And we've got a fairly complex system, and it's enough. That's it for the presentation. I want to show a couple of things here.
Go ahead.
Let's see here. I was going to do this. I'm going to bring up a client and N1MM. Ah, I already got it running. So this is all scrunched into one screen. Typically, we use 2 monitors. A moderately simple station can run with 1 monitor. Is this visible?
Yeah. Yes, it is.
Okay. I've got the tray for this. I'm on 40 meters at the present time. This is because I'm not doing PowerPoint. Okay. In the upper right-hand corner here, I've got the 40-meter antenna selections. This is a real rotator. Actually, that's the rotating tower. The low 40 is fixed at Europe, so that one's in gray. It's a fixed antenna. But I have it as an antenna here or a rotator because I want to include it in stack match. Um, I could just click on that or hit the multiply key on my keyboard, which I'm going to do now. You can't see me doing that, but I'm hitting the multiply key on my keyboard. And that's turning on and off the lower antenna. And there's a 40 south, which is on the subtract key. That's another rotator. You can grab one to do a preset just by clicking on it. Now, again, this works well with a touch screen. Then you click on the position, and once you click on it, it goes away. That's actually going to start turning. I'm going to stop it. I got somebody actually using the station right now. So I don't want to bother him in case he's on 40. um, let's see. There's map display. You can grab the wedge and move it. I'll just move it a bit. I've got an image here that's actually, that image is, I'm going to change it to just the compass. This is in my way here. Then that changes it to a compass display. My 8 circle for 40 meters is right here. I've got all my 8 circles set up to be used the numeric 4 and 6 key. So I'm just tapping the key and rotating it around. It's pretty responsive. And this is through Splashtop remote. No, this is a client I'm running here in Florida that's going TCP to the server in New York, and then wirelessly out to the 8 circle on 40 meters. The beverage switch. These band switches here, I guess the station's being used on 20. So I'm going to select, I'm going to take this off. Because it's off, it's not responding to automatic. But if I put it on 6 meters, so I'm on run 2, the station's in use on run 1, so he's on 20. So I'm going to just put this on 6 to turn it on. And now, depending on what band I'm on, when I go to 40 meters, goes to 40. If I go to 3510, goes to 80. Brings up the different selections here automatically. And anything else I need, like here's an 80-meter selector for the 4 square of the dipole. When I go to 160, the 160-meter stuff shows up. They use the same hotkeys, so must not have this one programmed in this client. But in any event, it uses the same set of hotkeys because you've only got the band you're interested in on screen. Just for grins, if I want to bring up the microwave stuff, if I bring my radio on 1296, now I bring up a whole different set of controls based on the frequency. These are some interesting, some stuff I use to control the microwave equipment that's all out at the base of the tower or on the tower. All 3 of these rotators per se are cloned off of HF antenna rotators, hence they're blue, but they turn independently and they have different offsets. My 6 meters are both 180-degree offsets from 15-meter antennas, one high, one low. My VHF UHF is actually on the 40-meter rotating tower. So when I turn this, I'm turning the rotating tower. It's selecting automatically the IF switch that's up on the tower for which band I'm on, or the IF switch that's in a different location for the VHF stuff. That's probably enough without going into anything crazy, unless somebody has a question about that. I'm going to close this up. Yeah. And I'm going to show you an old picture of, where is it here? Sorry about this. This is a particular mess. It's been cleaned up. This is what our back room would look like. Most of the rotor controllers are in the back room. The three bases, the server computer itself, which when I took this was probably an old XP box. I'm running Windows 7 on it now, I think. Doesn't take much resources. You want a reliable computer, of course, for it. And these Dell Optiplex commercial size or commercial size computers are really nice for that. The 8x4 matrix switch, the remotes for that. My bandpass filters are back here. Each one of these hard lines goes out to a band. Like I say, I've cleaned this up quite a bit since I took this. I took this as a kind of a joke. It's a mess, but it worked. Okay.
Excellent.
It's 11 o'clock. I'm done. Who's got questions?
Anyone? As a satisfied customer of the RT21, you Green Heron everywhere stuff, a lot of hardware there, a lot of software. Is the software open sourced or
It's not open source, but the jar it's free.
okay?
So yeah, it's not open source. It's executable jar files, and there's no charge for it.
Okay.
I'm gonna get rid of my there. I don't know how to make my Zoom screen come up back to where it was. I guess it doesn't.
You're still sharing, so
Okay.
just pick your screen you want to display.
Okay. I'm open to questions, and if not, I'll pass it back to you for whatever you wanted to do for the rest of the morning.
Okay.
No question.
Excellent.
Okay.
Excellent. Thank you, Jeff.
Okay. I'm going to stop this, I guess, or just back out.
Yeah.
Thanks, guys. Thanks for your time, and see you on the contest.
Yeah, thank you again. Really appreciate it. Jeff runs a groups.io remote site support site. He's very active in it. I can tell you that. Just curious. You building this stuff in your quote unquote garage, or do you use a CM to put all
Well,
this
I'm
stuff
actually in Florida. We build a lot of the board level stuff now is built overseas. The RT21 is built in Rochester, New York. I have a contractor that builds boards for that. I have another contractor that builds chassis. And in fact, those two people have the contractor that builds the chassis has done all but the first 20 ever since 2005.
Wow.
So he's done almost all of those 6,000. I've got a third. I have a shop tech that works 2 days a week, and he comes into a shop that is on the W2. It's on my home property in New York. It's a barn at the back of a barn. And it's a pretty well equipped shop. Of course, it's good for in the cold that we've had, and it's heated and air conditioned. It's a 16 by 32 shop. We do all configuration and shipping out of that, and final test. So there's three contract folks plus the shop tech.
Okay.
And I guess that answers that question.
Yep.
I don't build them. Not anymore. I built the first 10.
Excellent.
Anything else?
Anybody? Okay, again, I thank you, Jeff. You're welcome to stick around, or you're welcome to bail out, whatever works for you.
I'm going to bail.
Okay.
Okay. See ya.
Take care. Thank you.
Bye.